Okay, today we're going to talk about solubility curves. In the last lesson, we talked a little bit about what solubility is and the definition of solubility. And now we're going to use some solubility curves to decide whether something is saturated, supersaturated, or unsaturated. Okay, so to review from day one, from the last unit, from the last lesson, solubility is the maximum grams of solute, the maximum amount of your solute that will dissolve in 100 grams of solvent at a given temperature. We had said it was the maximum amount of solute that will dissolve in a set amount of solvent at a given temperature. We're going to define it a little bit more here, and we're going to say specifically, if you have 100 grams of solvent, what's the maximum amount of your solute at a certain temperature? So if you have salt water, your solute is your salt and water is your solvent. So it's asking you, how much salt can I dissolve in 100 grams of water at a certain temperature? Okay. Your solubility is going to depend on temperature. The warmer you are, if you're talking about a solid, the more soluble you are at a higher temperature. Okay. And your solubility is based on your saturated solution. When you talk about a saturated solution, we're talking about the maximum amount you can dissolve. Even one more drop of one more crystal of your salt will not dissolve because you've already hit that maximum. Okay, that's a saturated solution. So this is what a solubility chart looks like. We have many different ionic compounds on here. But what you'll see, and we've talked about this already, is the solubility of most solids, these are solids here, increase. This is your solubility on the left. This is your temperature on the right. So as you increase your temperature, as you go to the right, what happens? Your solubility increases as well. Your y-axis is your solubility in water. This is assuming in water. 100 grams of solute in 100 grams of water. Oh, that should say water. Okay. So as your temperature increases, as you go this way, your solubility increases. So for instance, at 10 degrees, KClO3, its solubility is about 5 grams of KClO3 will dissolve in 100 grams of water. But if you go to 80 degrees, at 80 degrees, you have about, 37, 38 grams of your KClO3 that dissolves in 100 grams of water. Okay? This shows you your effect of pressure. And every ionic effect of temperature. And every ionic compound has its own curve. Okay? The solubility of your subionic compounds as a function of temperature is your solubility curve. Most salts have a greater solubility in water. But then you've got a salt right here. Greater solubility in hot water. But then you have this guy right here. If you notice, as your temperature increases, its solubility decreases. There's a few salts that have a negative heat of solution. This is an exothermic process, and they become less soluble with increasing temperature. But you can read that off of the table, the solubility table. This guy, as your temperature increases, your solubility decreases. So at 0 degrees Celsius, it's got a solubility of about 18 grams of Ce2SO43. But if you go to, maybe 70 degrees, instead of having 18 grams being soluble, at 70 you're probably at around 5. No, probably less, like 3. Okay? So just be aware, you have to use the graph given to you. Okay? Now, those were for solids. Now, we talked about your solubility of gases, and we talked about how as you increase your temperature, the rate of solubility decreases for gases. and your actual amount that goes into solution decreases as well. So for most gases, now we're talking about gases, most gases decrease in solubility with increasing temperature. So for instance here, NH3 is a gas, and it is decreasing solubility as your temperature increases. Okay. Now if you do it versus pressure, you're going to have the opposite. So for gases, your solubility and your temperature are inversely proportional. And according to the solubility curve down here, this is ammonia is a gas. Okay. So again, just to reiterate, these are all gases. As your temperature increases, your solubility is going down. These are for gases: oxygen, nitrogen, xenon, and CO2. Okay. So let's talk about what's on our axes. A typical solubility curve shows the total mass in grams of solute. These are grams of solute. So if you're looking at this line, you're looking at grams of potassium chlorate. If you're looking at this slide, you're looking at grams of sodium nitrate. The total mass in grams of solute that will completely dissolve in 100 grams of water. So they're saying, assuming we have 100 grams of water, how much sodium nitrate can we dissolve if we're at 30 degrees? Okay. How much can we dissolve if we're at 30 degrees? When we say 100 grams of water, that is the same as saying 100 milliliters of water, since the density of water is 1 gram per milliliter. So 100 grams of water is the same thing as 100 milliliters of water. Okay, so if you are on the solid line, you're talking about a saturated solution. You can't put any more. If you are above that line, you are supersaturated, or you have a precipitate that has formed. If you are below your saturation line, then you are unsaturated. So you need to remember that. Above the line is supersaturated, or you have a precipitate that has formed. On the line is saturated, and below the line is unsaturated. You should see in Schoology this curve. You have a blank one available to you. I would suggest that you print it up and then color each line so we can use them. We can use it a little easier. So let me show you what that looks like. Okay, this is my solubility curve, the one I just showed you. Like I said, in Schoology, you have a solubility curve that says blank solubility curve. I'd like you to please print that up. Once it's printed up, I would like you to outline each line in a different color. You can use a highlighter, you can use colored pencils, you can use markers. Highlight them each in a different color because it'll make reading it a lot easier. Because then you're looking at things, especially when you get down here, you get this big spaghetti full of lines. It'll make it easier to distinguish them. So please do so. So how do we use solubility curves? How do we use solubility curves? So whenever you obtain a value from a solubility curve, the line on the curve, it is always for the saturated solution. So if you are a point on a line, you are talking about how many grams of solute you have in 100 grams of water, or 100 milliliters of water. Because your left axis, your y-axis, assumes you have 100 grams of water, and you're trying to find how many grams of solute you have. So if you are on that line, you are a saturated solution. If your problem does not have 100 grams of water, then you're going to need to use a proportion. You'll have to figure out how many grams of solute would dissolve in 100 grams of water, and then use a proportion to actually figure out how much solute you have. And I'll show you examples of this in a minute. Okay, so let's try some practice problems. So here, I have a solution at 60 degrees Celsius that has 80 grams of sodium nitrate dissolved in 100 grams of water. So we're in 100 grams of water. This is in 100 grams of water, so we don't have to make any adjustments. We're looking at 60 degrees Celsius and 80 grams of sodium nitrate. And we want to know if it is saturated, is it supersaturated, or is it unsaturated? Remember, if it's saturated, it's going to be on the line. If it's unsaturated, it's going to be below the line. If it's supersaturated, it is going to be above the line. Okay, so we're going to go to, first of all, we're going to find the sodium nitrate line. That's this one right here. So we're looking at it relative to this line. Okay, this is the line we're looking at. We're going to go to 60 degrees Celsius. This is the line we're looking at. We're going to go to 60 degrees Celsius. That's right here. And it wants you to go to 80 grams. So we're going to go 60 degrees Celsius and 80 grams. Right there. 60 degrees. So we're going to this point. And we're looking at where this point is relative to this line. If you're on the line, you are a saturated solution. If you're above the line, you are either supersaturated or you formed a precipitate. If you are below the line, you are unsaturated. Well, this point right here is below the line, therefore it is unsaturated. Okay? Is the intersecting point above, on, or below the line? It's below, therefore this is an unsaturated solution. That means you can still add more sodium nitrate at 60 degrees and still dissolve. You can add all the way up until you get to this point, which is like, what, 125 grams? And you've got 80 grams? You can add 45 more grams of sodium nitrate before you saturate your solution. Okay, let's try another one. What amount of sodium chloride would make a saturated solution in 100 mils of water at 80 degrees Celsius? Okay, first of all, we want to make sure we're in 100 grams of water or 100 mils of water. 100 grams and 100 mils are the same. So this is the same thing as saying 100 grams of water. This plot is for 100 grams of water. So this is, we don't have to make any adjustments. Now we're going to say how much sodium chloride would make a saturated solution at 80 degrees Celsius. So you're going to look for the sodium chloride line. It is this black line right there. And you want to make a saturated solution. So you want to find the point on the line. So you're going to go to 80 degrees, which is right here. You're going to go up, 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 up until you hit the sodium chloride line, which is right there. Okay, right there. How many grams of sodium chloride do we have? The answer is 39 grams. So this is 40, we have 39 grams. You've made a saturated solution because you're right on the line. Okay, let's try another one. What amount of sodium nitrate is required to saturate a solution of 100 milliliters of water? So you're going to look for the sodium nitrate line. That's this one right here, sodium nitrate. We're in 100 mils of water. Okay, this is 100 grams of water. That's the same. 1 gram is equal to 1 milliliter. So if we have 100 grams, we have 100 milliliters. So we don't have to make any adjustments. We're trying to saturate the solution. So in other words, we want to find the point on the line. So we're going to look for 75 degrees Celsius right here. Oops, 75 degrees Celsius. We're going to go up, 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 up until we hit this line. 75 degrees Celsius, we're right there. 140 grams of sodium nitrate. Remember, we're looking at the sodium nitrate line. Now let me do this on my colored solubility chart, just so you can see why I ask you to color it. Okay, so that last problem asked you to look for sodium nitrate. That is my line. That's right here, yellow. We're trying to make a saturated solution at 75 degrees. So we're looking at this yellow line, sodium nitrate. 75 degrees is right here. So I'm going to make a saturated solution, so I want to hit that yellow line. So if I'm going to find my 75 degrees is right around there, I would say. So as I go up, I hit the line right there. If I go over, I'm like right here, which is 139. We went to this point here, 75 degrees, went to this point here. That point there is 139 degrees. Okay, now let's approach this from the other direction. This question says, at what temperature would 25 grams of KClO3 dissolve? At what temperature would 25 grams of KClO3 dissolve? So we're looking for the KClO3 line. That's this line right there. And we want to say, okay, at 25 grams, so we're looking here, what temperature would it dissolve? So for it to dissolve, it needs to be saturated or unsaturated. If you're supersaturated, it's no longer going to dissolve because you are past that maximum. So we're trying to find the small lowest temperature that it will start to dissolve, which is that saturated point. Okay? So we're going to look here. 25 degrees is right here. We're going to go over until we hit the point on the KClO3 line, which is right about here. Which if you look, is okay, let's try a little more complicated of a problem. Okay, we have 80 grams of sodium nitrate at 60 degrees. Okay, 80 grams of sodium nitrate at 60 degrees. So we're looking at the sodium nitrate line. That is that one right there. And we have 80 grams at 60 degrees. So 60 degrees is right here to 80 grams. So we're looking at this point right here. So since we are below the sodium nitrate line, we are unsaturated. Okay, we are unsaturated. That means we can add more sodium nitrate to the solution and still allow it to dissolve. Okay, so the problem says, how much sodium nitrate could I add to the above to form a saturated solution? So we're here, okay, we have 80 grams. We want to go to this point, to the saturation point, okay? We want to go to this point. At this point, we're saturated at 124-ish, 124 grams. So if we already had 80 grams, how many more grams of solute are needed to hit that 124? So we would do 124 minus 80. I can add 44 grams from this point to this point. It's 44 grams. I can add 44 grams to this solution and still have it dissolve to make a saturated solution. Okay. How many grams of potassium nitrate will dissolve in 300 milliliters of water? Okay, now we have our first big change. This says 300 of milliliters of water. But what we have is 100 grams or 100 milliliters of water. We want to know how much will dissolve, potassium nitrate will dissolve in 300 milliliters of water. So let's look for the potassium nitrate line. That's that one right here. Okay. At 50 degrees Celsius, 50 degrees Celsius, we can dissolve 80 grams of potassium nitrate in 100 grams of water or 100 milliliters of water. We can dissolve 80 grams in 100 milliliters of water. How many can we do in 300? Well, it would have to be 3 times that. How many grams of potassium nitrate can we do in 300 milliliters of water? That's 240. So 100 grams we can do 80, and 300 we could do 3 times as much. Okay, so in other words, another way of looking at it is if in 100 grams you can dissolve 80 grams of potassium nitrate. If you don't have 100 grams, if you have 3 times as much, then you can put 3 times as much potassium nitrate, 240. Okay, let's try another one. I have a saturated solution with 9.2 grams of solute dissolved in 10 grams of water at 25 degrees Celsius. What is the solute? Okay, this one's a little bit more complicated. First of all, we have 10 grams of water. We don't have 100. Okay, so whatever we find, we're going to have to multiply by, to get it to 100 grams of water, we're going to have to multiply this by 10. So we're looking for a bit more. Okay, we're at 25 degrees Celsius. We're going to multiply 9.2 times 10, so it's 92 grams of solute, which makes a saturated solution at 92 grams of solute at 25 degrees. So we're at 25 degrees. We're going to go up. We're going to go up 25 degrees until we hit 92. Oh, that's that line right there, sodium nitrate. Sodium nitrate makes it saturated, not any of the other ones. Okay. Now this is which substance appears to be a gas, and how do you know? Well, the only one here that is decreasing with increasing temperature is ammonia. That is your gas. Your solubility is decreasing with increasing temperature. It's the only one. All the other ones are solids. Okay, so why don't you pause this video right here and see if you can try these three. And we'll come back and review them in a minute. Okay, the first problem we have says I have a solution with 100 grams of sodium nitrate dissolved in 100 milliliters of water at room temperature. What is room temperature? 22 degrees Celsius. Is it saturated? Is it unsaturated? Or is it supersaturated? So the first thing you have to do is identify what we're looking at. We're looking at this line right here, the yellow one. We're also looking at 22 degrees and 120 grams. So we're going 22 degrees. Okay, we're going to go right here. 22 degrees is probably right here. Okay, and we're going 120 grams. That's right here. So the question is this saturated, unsaturated, or supersaturated? We're looking at that point right there. Is it saturated? Is it unsaturated? Or is it supersaturated relative to NaNO3? Because it is above the line, this is a supersaturated solution. Okay, the next problem reads, how much potassium nitrate is dissolved in 100 grams of water at 50 degrees Celsius to make a saturated solution? So we're looking at the potassium nitrate line right there. We're looking at the potassium nitrate line. Saying you're in 100 grams of water. Okay, so that's this plot. We're not making adjustments. You're at 50 degrees Celsius. So we want to know, we're trying to make a saturated solution. So how many grams of potassium nitrate make a saturated solution if you're at 50 degrees? So we're trying to find the point on the line at 50 degrees. So you're going to go 50 degrees up. You can hit this point. Now you're going to go across to see how many grams of potassium nitrate it took. And it takes 80 grams. Okay. The next problem says, okay, I have 65 grams of potassium nitrate, so we're still looking at potassium nitrate, dissolved in 100 grams of water at 50 degrees. So we're at 50 degrees and we have 65 grams. So we're looking at a plot, we're looking at a dot right there. 50 degrees, 65 grams. How much more can be added to have a saturated solution? How much more can we add to get to this point right here, to get to that 80? So we're at 55. We want to get to 80. How much more can we add? 80 minus 65 to give you 15. Sorry, I think it's at 55. I meant 65. Okay. The last one. What volume of water do I need to make a saturated solution containing 1,000 grams of potassium chloride at 50 degrees Celsius. So we're looking at potassium chloride. That's this line right here. Okay, this line right there. We want to know how much water do we need? How much water do we need to make a saturated solution at 50 degrees? So let's look at 50 degrees. We're going to go up to the potassium chloride line, and you hit this point right here. That's 40. You have 40 grams when you have 40 grams of potassium chloride at 100 grams of water. Okay, so now we just have to solve for how much water. It's a proportion. We solve for this, we cross multiply, do our math, and we get 2,500 grams of water. Please practice.